Hello guys, sorry this is taking a while. Funny story. I recorded a great video, really good, probably about 10-15 minutes long, and it didn't save. So here I am, I got to do it all over again. Yay! But that's okay. It's okay, it'll be better the second time around anyways, right? I'm just gonna look at the glass half full approach. So here I go again, explaining the notes for the assignment. And yeah, you get to use Desmos, so make sure you have Desmos up. And so we are going to be talking about systems of inequalities. Hence, inequalities is the key word here. Okay, so we're looking at symbols like these: greater than, less than, greater than or equal to, less than or equal to. We're also going to be looking at systems, and systems, remember, just means more than one. So we're comparing more than one inequality, so more than one. So for instance, we're going to be comparing two. In this case, we're going to be comparing two, okay, no more than two. But we are going to be looking at two different inequalities. And remember, when we talk about inequalities, just like the symbol, and just like if we were to say x is equal to 2, well, x can only equal to 2, right? Because that's all. There's just one solution. But if we change that and say x has got to be less than 2, we now have an infinite amount of solutions, correct? Like tons, way more than just one. We can have x can be 1, it can be 0, it can be -1, and so on. So we've opened this door to so many different possibilities. So for instance, if I was to give you an equation into y equals mx plus b, so y equals 2x plus 5. Here's my line, right? It's this nice pretty line. Here's all my little solutions all along this line. However, watch what happens when I take this equal sign and I change it to any inequality. What do you notice that happens? Some shading. And the shading is there because not only are we talking about solutions on a line, we're opening up a whole different realm of solutions. And now the solutions lie all right here. Here's all of my solutions. And you'll see when I make Desmos bigger, it goes on and on and on forever and ever and infinite in this direction. And you can see we could go on forever. Okay, so that's the difference between equations and inequalities. Inequalities, we're going to be looking at a lot more solutions. Another thing that's important to remember, let me get rid of this, is that we're going to be looking at 2 or more equations. We know that. 2 more inequalities. But it's got to be the same variables. So we're looking at things that have a y and an x. It has to have a y and an x, and only a y and an x, because we're graphing. So we're looking at 2 different equations, and we're going to be looking at where do the solutions lie. And because we're talking about shading, and let me just put another one in here just so you can see. Less than 2, let's see, 3x plus 8. Okay, let's do a friendlier one. Plus 8, and then I'm going to actually change the sign to a greater than. Nope, to a less than. Just, there we go. Okay, so here are my solutions. So now we're going to see, here's my 2 lines that are being graphed, just like we've been learned. Our solution set now is where it is double graphed, and I'm going to show you. And this is what we're going to be talking about. My solution is going to lie only right here. These are all of my solutions because this covers in both of my equations. Not just one, but I want solutions with both equations that I put in. So if I'm talking about just the red line, here's my solutions. If I'm talking about just the blue line, there's my solutions. But if I'm talking about both, I need them to overlap. And that dark bluish purple is where they both overlap, and those are my solutions. So just things to remember as we do that, and it's really easy, guys, like I promise. The things to remember as we go through this are put your equations into Desmos exactly the way you see them. So whether they're in y-intercept form, like this one, or they're not, just put them in exactly the way you see it so you can pull up your graph. The next thing you're going to do is you're going to look for the double layered. Okay, that's important, where they're overlapping, because there's going to be a lot of shading going on. But you're looking for the double layered. But before we do that, we need to look at what the different lines mean. And remember, we just did this today. We're looking at a solid line. We already know what a solid line means when we're graphing. A solid line means it can equal to. It has the equal to. So we're going to be talking about either this one or this one. Not only do we need a solid line, what happens when we have a solid line and it's shaded below? What does that mean? That means those numbers are less than. So we would be using this symbol. We would say less than or equal. If it has a solid line and shaded below, it would be less than or equal. What if we had a solid line and shaded above? That would be greater than or equal to. Because again, equal to because it's a solid line, but shaded above because it's the greater than. And then we're going to talk about dotted lines. Remember, dotted lines means that they are not part of the solution, okay? But anything shaded this way is, or anything shaded that way is. Same concept. So what if I had a dotted line, but it was shaded below the line? What symbol would that be? And that would be the less than symbol right here. So just the less than. And then what if I had a dotted line that was shaded above the line? Well, that would be the greater than symbol. So these are the things we've learned today. That was easy. You guys got that really fast. The second thing we're going to look at are equations. So notice, here's your equations, and here's something graphed. Now, what is graphed and in the red is the solution, but I want to show you why, and I'm going to show you what that looks like on Desmos. Let me scroll in a little bit. And I'm going to put these equations in exactly the way I see them. Y is greater than -4. And then I'm going to put in, notice that's the green, and then I'm going to put in y is greater than or equal, less than or equal to -x minus 1. So -x minus 1. That's the equal sign. -x minus 1. Okay, so that is the double shaded. Do you see that? That's why. So here's your answer. Your answer is going to lie not in the green, not in the purple, but in the green and the purple right here, which is the same thing that's shaded over here. And that's why that's the solution. They're just shading the solution, but that's where it's coming from. And you can see that on Desmos perfectly. And it's going to ask you, is -3, -2 part of the solution? And let's look at where -3, -2 is. -3, -2 is right here. Is that part of the solution? Is that in the double layered section? Well, yes, we can obviously see that, but you can also use Desmos. You can put in -3, -2. That is not a negative, Miss Skinner. So -3, -2 into here, and you're going to get a dot. And is that dot in the double layered? It is. It's right there. So we would say, yes, that is part of my solution set. So you can go ahead and swing that up. That is, -3, -2 is part of my solution. Now what happens if I flip these and I said, well, is +3, +2 part of my solution? And I had to answer the question now. Is +3, +2 part of the solution? Well, obviously it's not because it's outside of the shaded. But you could also put that into Desmos. You could put in +3, +2. And as you notice, it is just in the green. Remember, it has to be in the double shaded right here. So no, it is not part of my solution set, which you can see it on both screens that it lies with outside of the double shaded. So no, it is not. So, but this one, the one that they give us, it's right there in the pink, and that one is. And then for number 2, we're going to put this one in exactly the way we see it. We're going to put in y is greater than -2x plus 2. And then we're going to put in 2y is greater than or equal to x minus 8. Okay, and it's obviously we can see where the solution set is. It's not A. A would be this green part right here. And I'm going to go ahead and label this. I'm going to screenshot, and I'm going to show you what they labeled. So they labeled this as A, right here. They labeled this part B, right there. They labeled this part C, right there. And they labeled this part D. So where does my solution lie? Does it lie in A? Does it lie in B? Does it lie in C? Or does it lie in D? And obviously it's right here. It is B. It's the double shaded area right there. So we would drag and drop this little dot, and the region where all of my solutions lie are B, right there. And you can see that on Desmos too. Okay, next screen, we're going to be doing the same thing. First, I'm going to put these in exactly the way I see them in Desmos. X is greater than -3. And then y is greater than or equal to 2/3 x minus 3. Okay, so here we go. And that's exactly what you're seeing, is the double shaded. So it's asking, is 0, 0 part of the solution set? So let's go ahead and put our dot right here. 0, 0 is right there. Is that part of the solution set? And the answer is yes. It is in the double shaded. And again, if you wanted to, you could put this into Desmos. And yes, you can see right there that 0, 0 is part of the solution. So that would be a solution to the system. 0, 0 would be. What about -4, -5? Sorry, +4, -5. So go over 4, go down -5. And the answer is no. And again, you can use Desmos for -5, and you can see that that does not lie in the double shaded area. So that would not be part of my solution. So we would say no, that is not. And that is a very good question, like that I would probably put on a test. It's that easy. Is it a solution, yes or no? And then you would just have to say yes or no. And again, you can easily put these into Desmos, and you can quickly look to see what's inside of a solution, like this red one, and what's not inside of the solution. And the next one, I'm not going to graph this one. I'm actually going to zoom in so you can see. But it's asking, is +1, +1 part of the solution? And the answer is actually no. And let me tell you why. What kind of line is that right there? That is a dotted line. Dotted line means, hey, this right here is not part of the solution, but anything down here is. And hey, this line right here is not part of my solution, but anything in this direction is. So that dotted line where that dot is not part of the solution. Now, if it was a solid line, then we could answer yes, absolutely. But because it is a dotted line, we would say no, that is not part of the solution. And it's not part of the solution because it's a dotted line, because it lies on a dotted line. It sits on the dotted line. And for it to be a solution, it would have to be solid. I'm just going to keep it simple, but that's basically what it means. Because it sits on the dotted line, it's not a solution. If it sat on a solid line, then it would be a part of the solution set. And then you're also going to get these special cases, and these are cool. And I'm going to graph these because obviously we know that parallel lines are no solutions, but they're going to look a little bit different in inequalities because there's still going to be some shading going on. But you're going to notice something about the shading. So y is less than x minus 2, and then y is greater than or equal to x plus 1. Okay, so my question to you, for it to be a solution, I have to have double shading. It has to overlap. Will these lines ever overlap? The answer is no. So for this system together, there will never be a solution. Ever. They will never overlap. Remember, for systems, we need them to overlap. And so the answer would be no solution. There will never be a solution to this problem ever because they don't overlap. They have two different sides. So we would say no solution. I'm actually not going to do 7. We will do 7 in the study guide. I doubt we'll have any questions like that on the test, but I will save one for it just in case when we have to come up with our own solutions. But for your time, I'm going to come back to that question and add something like that for the study guide. So we're going to go into the last part. What we're going to do is we're going to put, let me erase that. We're going to put these 3. We're going to put F, A, and B where they need to go up on my graph. So what I'm going to do is I'm going to put these into my into Desmos exactly the way I see them. So I'm going to put in 2x plus 4y is less than 12, and I'm going to put in 2x plus y is greater than 1. Okay, and I'm going to look. Here's my double shaded. Where is this graph? Is it 1, 2, or 3? And the only one that matches this graph, and be careful here. Do I have this one right? Nope, it needs to be a 12. I'm about to say. Is right here. No, be careful here. It would be 2. Notice that it is. I'm going to make this a little bit bigger so you can see. But the only one that matches would be 2. Up a little bit right there, up a little bit right there, and you can see that they match perfectly. So we're going to slide F over to 2, and we're going to try A. We're going to put in X is greater than 2, and Y plus 4 is less than or equal to 3X. Okay, here, I'm going to zoom out a little bit. So your double shading, and I'm going to take a screenshot so you can see, lies right here. Lies right here, and then up this way. So what graph, 1 or 3, matches exactly this double shading? And it would be right here. This would be the match. So 3 matches with A. So 3 matches with A. So I'm going to drag A up to 3. And then obviously B is going to match this one, but let's just make sure, because Miss Skinner can make mistakes. Let's just make sure that this is in fact right. And we're going to put this equation in exactly the way we see. Hang with me. I'm going to go over how to do the assignment next. -4, because there's one little tiny assignment, but it's tiny. 2x minus 4y is greater than 12. Okay, and yes, that matches perfect. That is the matching graph. You can see those are identical, and so that would be B. Okay, so what you're doing on your own. First things first. Let me drink Desmos. You are looking for solutions, and you're going to match these solutions to where they would be over here. And remember, the solutions are the double shaded. So there, anywhere where you see double shaded, those would be solutions to your problem there. And just look here. Yep, no double shading. So there's your answer right there. No solution. So you're going to go through these and you're going to match. So the first one is 5, -1. And I'm going to graph 5, -1 in every picture. 5, -1, 5, -1, 5, -1, and 5, -1. Where does the point 5, -1 lie in a double shaded area? And the only one it lies in a double shaded area would be this graph right here, the very first one. So this would be a solution to this problem. So that's all you're doing, and then you're going to do 3, 4. So you're going to go up +3, +4, and you're going to figure out which one of these graphs has a solution of 3, 4. And that's all you're doing. And once you're done with that, don't forget to press submit, and you are done for Monday's assignment. So if you did this assignment today, high five, you are done. Have a wonderful weekend, and you are done until Wednesday if you don't have any missing work. If you're doing this over the weekend, I hope you're having a good weekend, and high five to you, and I will see you Wednesday as well. And if you're not doing this till Monday, still you get a high five, you're doing it, and I hope you had a great weekend, and I will see you on Wednesday. So don't forget to take care of all that missing work, and I will see you guys soon.